Well, hello friends. Welcome back to the program. Today, we are going to work on Crash Reporter in Serenity, and it has some performance problems that I would like to improve at least. And let me show you one that I have in mind. So I noticed that if I get a browser crash somewhere, for example, by trying to open the ACID3 test, which currently crashes the browser, you'll notice that I have to wait for quite a bit, and then I eventually get a crash dump here, and then I wait a bit more, and I eventually get a crash window here. And a couple of things happen here. So when a program crashes in Serenity, the kernel will generate a core dump. And then it will put that core dump into temp core dump, which is a directory where we just put crash dumps basically. And then there's a service called crash daemon, which will notice that a new file has popped up here, and it will parse that file to learn if it's a core dump. And then if it is indeed a core dump, it will print out the backtrace from it, which we eventually saw here. And then finally, it will spawn this GUI program that shows a window with information about the crash. And the stuff that Crash Daemon does to print out the backtrace is completely duplicated work then again in the Crash Reporter GUI program, because both of them open the core dump, parse it, and resolve all the symbols from dynamic libraries and stuff based on the addresses. And this is something that makes crashing feel very sluggish on Serenity, because we're doing all of this work just to be able to show this window. And we could do a lot less of it if we had some way for Crash Daemon to sort of hand over the information that it has learned about the crash to this GUI program, which really just wants to display it. So my thinking is that we would come up with a way for Crash Daemon to parse out everything and then turn it into like a JSON blob or something, where we have like a blob of data that we can then just hand over to the GUI program, and then the GUI program doesn't need to actually load and reparse the core dump, but instead it can just immediately display whatever the Crash Daemon has already figured out. And I think that could make crashes feel more snappy, which I know it's a bit of a weird thing to want, but yeah, I'm pretty used to seeing crashes, so I like for them to show up faster. So yeah, that's what we're going to try to do today, basically. So make Crash Daemon produce a sort of miniature core dump that's actually just a JSON object with the information that the GUI needs, and then we make the GUI, instead of parsing a core dump, it would just take one of these miniature core dump JSON things and display whatever's in that. I think that could be pretty cool. So let's see how we would do that. So I guess Crash Daemon has to learn how to do this. So in Crash Daemon main, we can see how it works. So basically it creates a blocking file watcher, and then it adds a watch for temp core dump, where it will listen for child created events. So whenever a child is created in that directory, meaning that a file has been added to it, this watcher will get an event. And then here we have an infinite loop where we just wait for such an event, and then get the path of the event. And then we wait for the core dump to be ready, which means that we stat it in a loop, waiting for the file to become readable. And if it's not readable, we sleep a bit. Oh yeah, right. So I remember this. This is in the kernel. When the kernel is producing a core dump, it will create a file on disk, but it doesn't make the file readable until it has actually written out the complete core dump. So this is just a way to signal to Crash Daemon from the kernel that, okay, you can take this file now. Like, this core dump is complete. So we're waiting for that here. And then we compress the core dump to save space. What does it do? So we create a .gz, we gzip compress it. And actually, I mean, it's important to save space because core dumps get big, but we could probably reorder things here a bit, and only start compressing it once we have thrown the GUI up on screen, because that would also make things feel a lot snappier. So basically, actually, let's time this. I want to find out core elapsed timer. Let's find out how long these steps are really, because now I'm kind of curious. So elapsed timer start new. Yes, that's how you do it. So we compress the thing and then we say debug line compress time. Compress core dump took this many milliseconds. Timer elapsed. And then let's print out how long it took to, damn it, this is a bit messy. Compress timer. Let's print out how long it took to print the backtrace as well. Backtrace timer. Because I realized that maybe I'm focusing on the wrong thing here. Maybe we can get a huge win already just by reordering so that we show the GUI before we do the compression. Backtrace took this many milliseconds. Backtrace timer elapsed. Okay. Yeah, and then let's just go to the ACID3 page, get a crash. Okay, so compressing that core dump took 1.5 seconds. Generating the backtrace took 3.3 seconds. And then we launched the GUI, which will then generate the backtrace once again, presumably taking another 3.3. Although it might be that we cache some things here. So like this pulls every library and everything into cache, which means that Crash Reporter actually has a bit less work to do. So let's just for our own information's sake, GUI backtrace. Yeah, let's time it here as well. What do you get out of this thing anyway? Does this thing parse everything? Backtrace, constructor. Constructor appears to do the work. Yeah, it does a symbolication and iterate. Yeah, okay. It's a bit of a unfortunate setup, this whole thing here, that that we're doing everything twice, but that's what we're here to look at. So let's see. So timer is core elapsed timer start new. Sure. Just to verify what we're working with. Okay, so compress 1.5 seconds, sure. And then the backtrace 3.4 seconds, and then the GUI 1.5. Okay, so when the caches are hot in the GUI, it only takes us 1.5 seconds to generate the backtrace once again. So basically, that is I would say that's sort of the ceiling of how much we can save here by doing all the work in the crash daemon service program instead. And then if we reorder so that we throw up the GUI right away, we throw up the GUI right away, then the compression, like it doesn't matter how long the compression takes because nothing else is waiting for it. You know, maybe you have the CPU spiking while the crash dialog is on screen, but that doesn't really matter that much. So that seems like a really good idea. But in order for that to make sense, we have to be able to start the GUI right away. Also, wait, we compress the thing. Does that mean that the GUI is decompressing it? We compress it, and then we call launch crash reporter, core dump path compressed. Wait, what does that mean? Compressed is the return value from compress, which is false if we could not compress, true if we could compress. Okay, so that means that we are compressed, which is why it's called compressed. And we launch crash reporter with compressed. Oh, okay, so we pass that as the unlink after use flag. Okay, so we're passing in the original core dump to the crash reporter GUI program, and then we're presumably telling it to unlink the original core dump once it's finished with it. So crash daemon parses the core dump, compresses it, and then gives the uncompressed version, the path of the uncompressed version to the GUI program, which then parses it and then deletes it. Let's just verify that that's what's happening. So unlink after use is a command line flag. Delete the core dump after it's parsed. Sure. It's right here. So we remove the thing, and we do that straight after we have parsed it. Okay. Okay. Wait. Now I'm kind of questioning, like, why don't we just print out this stuff in the GUI program? Like, why do we have two programs in the first place? I'm sure there's a reason. I just I'm trying to remember what it is. Like, is this about, like, crash daemon is supposed to be like a privileged service or something? So crash daemon runs as my user account. Which is fair, but why can't it just why can't it simply maybe I'm thinking about this all wrong. Maybe instead of a handover protocol, what we want to do is just start the GUI program right away, crash reporter, because we always do that. Like, we're never not launching the crash reporter. So what if we just launched a crash reporter and then compress after we've launched a crash reporter? Seems fair. And then we don't print a backtrace here, which means that the GUI program gets to do all the fun work of parsing the backtrace. Yeah, let's reorganize things that way, see how that goes. Okay, well, my original idea is just morphing here, but I think that's probably healthy. So the compression, let's do get rid of print backtrace. We don't need that anymore. And let's just make sure that we print the backtrace in the GUI crash reporter when we're parsing it. So here, essentially, we just do this thing. Backtrace. Oh, wait, that goes in here. Build backtrace. So I guess we can just put it there. Backtrace entries. Is that a heavy object? It's a copy, but it has no reason to be a copy actually. So we can actually make this a little bit lighter. Thread info can be, okay, so all of these things can be const references, which will make this cheaper as well. Debug info cache. Okay, I mean, so this tiny little change here to the core dump backtrace API already saves us a bunch of work. And it's a trivial change, so let's just commit that. Lib core dump. Make backtrace getters return const references. Yeah, I mean, that's just a straight up obvious change. And then, because now iterating over the entries, it's not expensive, whereas previously it would have been. Okay, so I think that's okay. And then crash daemon print backtrace goes bye-bye because we don't need you. Simple as that. Okay, so now if we simply compress before we launch, let's see how that changes timings. Because now all of, like, it will be cold cache. So we should see that 3-second plus time in the GUI instead of a 1.5-second time. See, so we got the crash, and then we compressed it 1.5, and then the GUI eventually, poop, right there. And how long did that take us? GUI backtrace 3.2 seconds. Yeah. So we moved the cost to the GUI, but we still have, we've already now saved 1.5 seconds simply by not bothering to print out the backtrace in the crash daemon program. Instead, you can see here the crash reporter is now printing out the exact same backtrace as crash daemon was previously doing. So this is already great, I think. Now we just need to reorganize things so that we are compressing after we launched. Of course, the issue there is that who's responsible for deleting the uncompressed version? So the GUI wants to read the uncompressed version. So we're passing that here, and we're telling him unlink after use. Oh, wait, maybe that's okay though, because then we just need to make sure we open the core dump here. So yeah. So we'll memory map the uncompressed core dump here in the daemon, and then Crash Reporter is free to unlink it. And then that will just be fine. So this guy will always say unlink after use. Wait. What if compression fails though? Yeah, that's a little confusing. But why would compression fail? Compression failing. Maybe that's not a contingency we should care too much about here. So let's see. To compress this, we have to map the file first of all. So let's map it. If we're unable to memory map the core dump, then we're not going to be able to do the crash reporter either. So at this point, this is like, I'm just checking if memory map will report that error. No, it won't. Okay. So debug line, unable to map core dump. And the error string, so core dump path followed by filer error, error string. Okay, and then I think we'll just keep going at that point. And we'll leave that file in the temp directory for you to figure out what the heck that is if we can't map it. But if we are able to map it, then now we have it mapped. So then it's cool to go ahead and launch the crash reporter. Should be fine. And I think we'll just always say unlink. For now, let's just do it this way. And after that has spawned, then we can go directly into the compression stuff. Another option is to do the compression later, because like thrashing the CPU, like you get a crash, right? And then you immediately start producing the backtrace and everything. You're churning the CPU, and then you're done with that, and you're like compressing everything. You're churning the CPU even more. Like, is that really what you want to deal with when your system is crashy? I don't know. This is one of those strange things where it's not obvious to me what the best solution is. But instinctively, it feels like something incremental would be the best. Like if you could occasionally, when the system is sort of at an idle state, then you would notice that, oh, I have some uncompressed crash dumps here in the temp core dump directory. I can just go and compress them. But not sure exactly how that should work. That's something else to think about, but let's not try to solve that now. For now, we'll just do the compression here right after spawning the GUI and see how that turns out. So of course, now we have to change the logic a little bit. So compress core dump. Instead of taking the path, it can just take the file. So release value. So it will get a non-null ref footer to mapped file. Look. So we'll call that core dump file. Okay. Oh, and then I guess it wants the path in some cases, so we can still pass it in. That's fine. fine. I guess if it fails, then we don't need to log how long it took. Okay. So the idea now is to get the GUI up as soon as possible after we hit the crash. So there's the crash. And there's the GUI. But now we have this problem that the compression actually... The compression, of course, starts immediately after we launch the GUI. So it's still... Now it's running sort of alongside the GUI. They run in parallel. So the GUI backtrace here takes 3.7 seconds and the compression takes 1.6. So when they run in parallel, it actually slows things down a little bit, which is unfortunate, but I guess that's to be expected. Our kernel scheduler is not very mature. So, what is a good strategy for that? I guess something we could do is, I mean, we could have the responsibility of compression move to the GUI, but I don't really love that. We could wait for the GUI program to exit and only then do the compression. I don't hate that, although it is a little bit weird. We could have an artificial delay, so we compress after a while. I wonder if that's, is that a good idea? I'm not sure that's a good idea. But just for the sake of testing, what happens if we sleep for 5 seconds here? And then compress, right? So what does that do to the feel of it all? So there's the crash. There's the GUI. GUI took how long? 3.2 seconds to show up. And we eventually compressed it. And it took 1.3 seconds. So like both the GUI and the compression were faster in this case. And one thing is that the GUI program, we don't show a window on screen while we're parsing the core dump. That could be also something to make this thing feel snappier. Is that we could like pop up the GUI, but it could say like parsing core dump or something like that. You could have a sort of a progress bar even. That might actually be really awesome. That could be really awesome, actually. But yeah, so I obviously don't love that we are now doing a sleep 5 here. That's pretty weird. So compressing core dump took, yeah, let's say that. How long? Oh man, there are like so many different approaches to this, but I can't decide which one I like better. So I'm going to leave this one as a fix me, and I would love to hear people's ideas about what would be a good approach here. What do you think we should do? Like we have the crash reporter GUI is launching and it has to parse the core dump. So it's kind of a bad time to also run the compression of it, right? The compression can run at any time later that's fine. But when? And yeah, also like introducing a sleep here means that we are not going to process new crash reports, but that actually seems like it might be a nice thing, because it means that we won't flash up like tons and tons of crash reports, but it will sort of get to them in an orderly fashion. Let's go ahead and put a 3 there though. Fix me. This is a hack to allow crash reporter to parse, to give crash reporter time to parse the core dump before we start compressing it. I'm sure there's a much smarter approach to this whole thing, and we should find it. Yeah. But you don't always have to figure everything out at once, so let's just do the hack here. And I think at this point we can do a commit. So let me just tweak the thing here. So generating backtrace took, just making sure that the logs look nice. Also, what does this thing return even? Metadata. Metadata. Is that something that we have to do multiple times? Okay, so crash. Oops. Crash daemon plus crash reporter. Reorganize. Do less stuff. Streamline. Let's say streamline crash reporting a little bit. Before this patch, this is what would happen after something crashed. Crash daemon finds a new core dump in /temp. Crash daemon parses the new core dump and prints a backtrace. Crash daemon compresses, gzip compresses the new core dump, gzip. Crash daemon launches crash reporter, path to uncompressed dump. Crash reporter parses the uncompressed core dump again. Crash reporter displays a GUI. Is that the right order? Let me just verify. So previously we would compress first, actually. Okay, so I got that wrong. Uncompressed core dump prints a backtrace. And here, crash reporter unlinks the uncompressed core dump. This was taking quite a long time for when dealing with large programs crashing, like browser's web content processes. new flow. Crash daemon finds a new core dump in /temp. Step 2, crash daemon launches crash reporter. Boom. Crash reporter. Oh, wait, hold on. Crash daemon maps the uncompressed core dump. Right. I mean, we don't have to say that it's uncompressed, but let's say it anywhere just for clarity here. So crash reporter parses the uncompressed core dump crash reporter displays a GUI. Oh, wait, but it unlinks first. So crash reporter unlinks the uncompressed. Crash daemon, let's see, launches 3, 4, crash daemon goes to sleep for 3 seconds. Fix me. Well, this is a hack, let's say. Hack alert. Crash daemon wakes up. After step 4, crash daemon compresses the core dump. Jeez. Yes, so this is basically too long didn't read. We no longer parse the core dumps twice, and we also launch or prioritize launching the crash reporter GUI immediately when a new core dump shows up, instead of compressing and parsing it in crash daemon first. The net effect of this is that you get a backtrace on screen much sooner. That's pretty nice. Yeah, so that's pretty nice. The sleep, of course, is very, very hackish, but we don't have to solve everything right now. I am keen, though, to do some kind of a progress bar while it's parsing, because I guess that's one of those things that would make the system feel a lot more responsive if, like, it's working on something and you can see sort of the CPU meter down here is going to start like spinning up, but you don't know what's going on because there's no other indication. But if we throw up the GUI right away, that would be cool. But how would that work though? How would that work? So crash reporter, build backtrace. So this guy right here is the workhorse, really. And we are iterating through a vector. So we have sort of the foundation of a progress bar here. Let's see how that could work. So if we iterate through this size and then ++I, sure, auto entry is backtrace entries. Sure. And then what we're going to do is we're going to print out the number just print out the number. And then, yeah, so something like that. And then just to see if we have something that we could turn into reasonable feedback. I don't know how this would actually look, but we should see on the debug console. Okay, so there's our crash, and then no. Oh shoot! It all comes right. Because we're just iterating over a vector. Of course, that's going to be fast. All of the stuff happens in here in the backtrace constructor. So okay, so what if we give that thing a callback though, like an optional callback? Progress. Let's call it like on progress. We'll just allow you to do that, and you don't have to provide it, but you can. And then if we have one of those bad boys, then function void size t on progress. Sure. So this is a little bit goofy, but let's try it. So here, oh shoot, we don't know how many yet. I guess we could do a quick walk to determine how many entries there are. Yeah, in order to display progress, that's what we have to do. First frame. Okay, so let's say BP just replicate this walk here. How does that work? Start BP. Yeah, okay, let's do it this way. Okay, sure. We don't have to do this part. Yeah. And then this part we just do again. Sure. Okay. So frame count plus frame count, let's say. Can do that right there. Okay, and now we log our progress. So if on progress, frame index and frame count. Sure. And probably somebody should actually register for that. So obviously that doesn't go here. So this we can actually undo all of that gunk. But we have to pass it in when we want to generate the backtrace. So here. Okay, it's kind of funny that we're using that as a test. Yeah, look at this. Okay, that's definitely something we could use. Also, you could actually tell when this jerk starts compressing, that progress slows down. But yeah, I think we do have something there that could be used. Maybe we should have gone with 5 seconds there. See if that would make progress way faster on the GUI. Get the crash, look at those numbers coming in. No, that didn't really help actually. Okay, so let's leave that alone. But it's interesting that like it does a couple of them just fine, and then there's a heavy one, I guess, where it has to page in some big library like libweb or libjs, and then it takes longer to actually symbolicate those frames. But yeah, so let's see, how would we turn this into a GUI? This is kind of a really weird thing, because we don't have a GUI on screen yet at this point, but we could sort of make a really goofy intermediate window here. So let's see how we would actually do that. There are ways to do things. Progress window is GUI window construct. So then we would say that progress window set. What did we call it? Set title. Crash porter, let's say. Set not title. We want to have a very simple UI. So main widget is a simple. Let's do the absolute simplest thing for now. So we'll just make a progress bar. This is not going to look great, but let's just do it anyway. Also, I'm going to take some credit for this business that we're doing right here. Shout outs to Linus, who wrote Crash Reporter, one of the best programs in the system. Okay, and then I guess we can call that progress bar. Progress bar set. Oh, we don't know that yet. Okay, so at this point, we just want to show that thing, and then now comes the tricky part, because we don't actually have an event loop here. There exists an event loop, but, or does there exist an event loop at this point, actually? We're just parsing. Create, we're building the backtrace. Have we made the application object? We haven't. Okay, let's make the application object first. Just because. So we're able to do cool stuff like this. And then that means that we have an event loop, which technically means that we should be able to pump our event loop. We should be able to. Let's see. GUI application, oh no, wait, hold on. Core event loop current pump, and then core event loop wait mode. Just pull for events, bruh. If there are no events, then we don't block and we just keep going. In theory, that should work. In theory. And then once we have the thing finished, then we can just close the window. Oh my goodness, I don't know. I don't know if this is gonna work. This is really hackish. Oh yeah, of course, and then we actually have to set the progress. I have to set the progress bar here so that something meaningful shows up. Set max to frame count, I guess. And I mean, the max we're ever going to reach is actually, well, let's set the value to frame index +1. Yeah, so that we can actually reach 100%. Even though it's a little bit weird, we'll still look neat. Okay. Oh, look at him. Oh. That's pretty cool. Oh man, that was pretty cool. Does it update automatically though? Or does it get stuck? No, it actually does. Update a little bit. What if I like keep mousing over it? That doesn't help. Okay, so that's actually really good. Yeah, so we could just do a slightly better UI. I mean, this is a little bit goofy. Like, we show a very simple progress window ASAP to make crashing feel more responsive. Yeah, so that's what we're doing here. So say progress window set rect. Let's make it really quite small. So like 240 by 140 or something. Oh, that's not a rect, that's a size. And then progress window center on screen, sure. And then let's have a slightly more complex UI. So set main widget. Set the layout to a simple GUI vertical books layout. Sure. And then this becomes a child of the main widget. Sure. And the main widget also gains. Let's add a simple GUI label. Everybody's favorite GUI widget. Okay, so GUI label. And what do we say there? We say like set text. Oh, we can probably put it here actually. So loading core dump, let's say. Or like generating crash report. That sounds kind of cool. Also, maybe the progress bar has some interesting property, like, can we get a percentage? Doesn't it have some percentage thing? Progress percent. Progress set format value / max. Oh, we have, oh, okay. So I thought the format was going to be a format string for some reason, but yeah. So format percentage. Yeah, percentage is nice. What is the default format? Wait, oh, it was percentage. Oh, we're already seeing percentage. I'm just being stupid. Okay, so that's probably okay. Maybe I was just overthinking it. So let's see how that looks. We don't need to name that label, actually. Yeah. You get a crash, and boom, we're up. And it looks a bit bad, but it's better. And I think I'm going to write this UI in C++, but I'm going to use the GML playground just to sketch out how I want it to look like. So we have this tiny thing, and we have a vertical box layout, and we have a GUI label with the text like generating crash report, something like that, right? And then and we kind of want this whole thing to be this thing wants to have a fixed height of 30, let's say. And then maybe the progress bar also wants a fixed height of 22 or some aesthetic number like that. Fixed width of, I don't know, like 100? 140. Oh, shoot. We should probably make it a bit wider. So 160. Yeah, I mean, something even just like that would be pretty cool. I like it. I like it. So let's just tweak those things. We actually do need to name that label. .30, and then progress bar set fixed width 140, set fixed height 22. Let's fill that with background color for the aesthetics, and let's test it out. Oh man, that's awesome. Although it's just, obviously it's too tall, but I love that it comes up so quickly. What's a good height? 80 maybe? Progress window set resizable. False. You cannot resize me, bruh. Okay, just crash. That is so cool. It's still too tall though. But how cool is this? I just really enjoy what we're doing here. This is, so the factoring here is a little, you know, janky or whatever, but yeah, this is just so neat. Yep. Absolutely beautiful. So let's see, progress window. So let's factor that out into a separate function because it's so incredibly gross the way we have it right here. So let's see, create progress window. Do maybe like that. Yeah. And then return window. So maybe we show that here. So like auto progress window, create progress window. Sure, window show. And we actually need a pointer to the progress bar. So no. Let's be idiomatic here. So what would we do if we wanted to access the progress bar from the outside? We would set a name on it, progress bar. Or in fact, we could even do like this. Auto progress bar is progress window, main widget, find a descendant of type named GUI progress bar. I guess, yeah, I still have to name it something, so. Yes. And then we simply star that. Yeah, so it's still like, this is not the most beautifully factored thing. Yeah, like it's not the most beautifully factored thing, but it is a kick-ass feature. So I think we're gonna leave it like this for now, and then it's something that we can come back to once we have, you know, a clear head and can think of some nice way to factor it all. But this is just so cool. Like the fact that we have a visual clue now that this is happening. I love it. Love it. Okay. And it's also a lot faster than before. Just absolutely excellent. So let's see. Crash reporter plus lib core dump. Wait, did I do something weird here? I don't think so. Crash reporter plus lib core dump. Yeah, I'm not super happy with the API change I made to the backtrace class either. Like giving a callback to the constructor, like it's kind of weird, but sometimes, you know, sometimes you just have to accept that you're not going to have the most beautiful architecture when you first build a feature, right? The important thing is to come back to it and to iterate on things over time. But that's something that's important to me to show on this channel, where I do hacks to get things working, and then I also come back later and work on them and improve them. Just like today, we're sort of improving the situation with the crash reporter and crash daemon, right? So they were implemented in a way that works, but it turns out it was pretty slow. So we come back today, make it faster, and then we leave some stuff for our future selves to make even better. Anyways, show progress window while loading crash core dump, let's say. Some core dumps take a long time to symbolicate. So let's show a simple window with a progress bar while they're loading. This makes not super happy with the factoring of this feature, but it's an absolutely kick-ass feature that makes crashing feel 100% more responsive than before, since you now get a GUI feedback almost immediately after a crash occurs. I didn't mean to do that twice. Yeah, so definitely some work to do to improve that. Also, We probably should have left a little note here. Walk the call stack in order to provide progress updates. We first have to walk the call stack to determine how many frames it has. Yeah, let's include that little comment there so people can understand why we're doing what we're doing. Okay, so I think this is going to be the end of today's video. If you made it this far, then I thank you for watching and for hanging out. I am really happy with the feature that we have built here. I'm happy with the improved performance of crashes. And you know, there's a lot of things that we need to do better and improve, but I think this is absolutely kick-ass already. And of course, this should be really fast. Yeah, like you don't even get to see that little progress window for just a split moment there. Oh, we should probably not log these actually. Where did I put those? Was that in Crash Reporter? Yeah, right there. Yeah, I didn't want to have those in there. Yeah, so I think it turned out cool, and let's keep working on it. So thank you very much for hanging out, and I will see you next time. Bye.